Hello students, welcome back. Now we're going to move on to a very important topic, that is homologous series. My dear students, in my opinion, there should be a question from homologous series in your board examination, and therefore I mark this topic as a very important topic. Let's ace this topic with the following questions. Now this is an NCERT question, exercise question. What is a homologous series? Explain with an example. Now, my dear student, this is a direct question whose chances of coming for board examination is less. But we need to understand this so that we are able to do hot kind of question if they are asked on this particular topic. So what exactly is a homologous series? They say a series of compounds that have the same functional group. This is important. They have to have the similar functional group. All members of a homologous series have same functional group and similar chemical properties. Why do they have similar chemical properties? Because functional group decides the chemical properties. Now, since they have the same functional group, they're going to have the same properties. In which the two consecutive members means one after the other. They differ by a CH2 unit. Now, to understand this definition, let me give you an example. Now, this is the alkane family. I've told you how we are able to find out the first 6 members or first 5 members of alkane, alkene and alkyne family in my last video. Alright. So now look at these members. These are consecutive members: methane followed by ethane, then propane, butane, pentane, hexane, right? Now you know the formula of methane is CH4 and ethane is C2H6. Look at the difference in them. Now what do you mean by difference in the structural unit? You have C2H6. Simple maths. What if I subtract CH4 unit from here? We have 2 carbon and here 1 carbon. You get CH2. So I can say the difference between these two consecutive members is of CH2 unit. That means if I add CH2 to CH4, if I add this, right, I will get C2H6. Fine. Now if I add CH2 to C2H6, let me say this is a unit, you get C3H8. Similarly, if I add CH2 unit to C3H8, I get C4H10. Now, can I say the two consecutive members differ by a CH2 unit? That is one characteristic property of your homologous series. Number 2, all of them have the same functional group. They have carbon-carbon single bond, right? So they have the same functional group and therefore they have the similar chemical properties. Now, if they differ by CH2, let's calculate the molecular mass of a CH2 unit. Carbon has a molecular mass of 12 U and each hydrogen, one hydrogen has 1 U, so 2 hydrogen means 2 U. So CH2 has a molecular mass of 14 U. Can I say if two consecutive members differ by a CH2 unit, that means they differ by a molecular mass of 14U? Let's take an example. CH4, what is the molecular mass of methane? Carbon is 12 and hydrogen is 4, so it is 16U. Now, what about C2H6? 12 into 2, 24 plus 6, that's equal to 30, right? So the two members, one is having 16U, the other is having 30U. Can I say they differ by a unit of 14U? That means if I add 14 to 16U, the molecular mass of methane is 16. If I add 14, I get 30U. I get the molecular mass of the next member. So they differ by a unit of CH2 or molecular mass of 14U. They have the same functional group and therefore they show same chemical properties. Now, slowly the molecular mass is increasing. This was 16U, then you have 30U. I'm going to add another 14U and I get the molecular mass of propane. That's 4 plus 4, 44U. If you want to check, carbon is having 12, 12 threes are 36, 36 plus 8. So that is equal to 44. Again, if I add 14U to propane's molecular mass, I get 858U. That is the molecular mass of butane, and further on. So all of them differ by a unit of CH2 and a molecular mass of 14U. Now, if you can see that the members, now if you see carefully, that the molecular mass is increasing as we go down the series. Fine, 16U, 30U, 44U, 58U, and so on. Now, since the molecular mass is increasing, the physical properties of members of a homologous series show regular gradation. You know, the term is gradation. That means a regular change in physical properties. For example, the melting point goes on increasing as we go from methane to hexane. The boiling point goes on gradually increasing as we move from methane to hexane. So these were all the characteristics of homologous series. Let us quickly revise all these characteristics once again by taking alkene family, right? Now all of them have the same functional group, that is a carbon-carbon double bond shown by the suffix -ene. Since they have the same functional group, they show similar chemical properties, right? Now, the two consecutive members, one after the other, differ by a unit of CH2. So you have C2H4. If I add CH2 to the first member, that is ethene, C2 and one carbon here, C3, H4 and another 2, H6, I get the next member. Again I add a CH2 unit, I get the next member. So the two consecutive members differ by unit of CH2, represented like this dash CH2. Alright, that's a unit. Okay, so this also, if I add CH2, I get the next member, that is pentene. If I add CH2 to pentene, I get the next member, hexene. Alright, now since they differ by unit of CH2 and CH2 carries a mass of 14U, I can say each of these members, consecutive member, differ by a molecular mass of 14U. Right? Now, as the molecular mass increases as you move down the families from the first member, now this is not number of carbon atom, this is the first member. From first member to second member, third member, fourth and fifth. As I move down, the molecular masses increases. Now, since the molecular mass increases, the physical properties show a regular change, a regular gradation. Their melting points will increase, the boiling point will increase. The reason you're going to study in higher classes. But if it is asked for class 10th level, the molecular mass is increasing, they're showing a regular increase, and therefore there's a regular gradation or change in their physical properties. Their physical properties vary, but the chemical properties remain same because chemical properties are governed by the functional group, and they have, that means all the members of homologous series have the same functional group. I'm sure now the topic of homologous series and the characteristic of homologous series is clear to you. So let's come back to the same question. What is homologous series? Explain with an example. So this is the definition of homologous series, and you can give any example, let's say alkane, alkene or alkyne. Here again I'm going to tell you a very important topic, that is lower and higher homologue. Let me circle this propene. If it is asked what is the lower and higher homologue of propene, this is propene. If you go one step down, if you subtract CH2 from propene's formula, it is C3H6. If I subtract CH2, I go one step down, I move to ethene. So ethene here is the lower homologue of propene. Fine. And if somebody asks you what is the higher homologue of propene, you go one step up, add one CH2 unit. So you go one carbon up, and so butene is your higher homologue for propene. If somebody asks you what is the lower homologue of ethene, obviously there is no lower homologue for ethene. But if somebody asks you what is the higher homologue of ethene, you're going to go one step up. The higher homologue of ethene will have one more carbon, two more hydrogen, and that will be propene. Is that clear? Fine. Let me take up one more example. If you have, let's say, butane. Somebody asks you the lower and higher homologues of butane. So butane, 4 carbon atom, it's an alkane family. So C4H10. Why? Because I applied the formula CnH2n plus 2. Now if I subtract one CH2 from here, I get C3H8. This is C3, so it's going to be propane and it is the lower homologue. This is the lower homologue of butane. If I have to find out the higher homologue, I'm going to add another CH2 unit and I get C5H12. C5 means it's going to have the name of pentane. This is the higher homologue of butane. This is very, very important. You should be able to find out the lower and the higher homologue of a given compound. All right. So let's move to the next question. Give any two characteristic of a homologous series. Here I have listed 5 characteristics and this is important. Board might ask you any two characteristic. You can choose any of these. The simplest one are the consecutive members. They differ by a CH2 unit. They have the same functional group. The consecutive members differ by a molecular mass of 14U because the mass of CH2 is 14, 12 of carbon and 2 of hydrogen. So that makes it 14U. Since the chemical properties are determined by functional group, they have similar chemical properties. But since the molecular mass increases as we move down in the series, the physical properties show a regular gradation. For example, the melting and boiling point increase with increasing molecular masses. So we have done the characteristic of homologous series. If it is asked with the help of an example, you can take example and then explain two of the characteristic. Let's move to the next question. This question number 3 is an NCERT question. It's NCERT exercise question basically. Now since this is a multiple choice question, the probability of it being asked now in boards is slim. It's quite narrow. It's just less. It's NCERT exercise question. But let's see which of the following is not observed. You have to find out not observed in a homologous series. Change in chemical properties. This is incorrect. Chemical properties remain same. Difference in CH2 and 14U molecular mass, perfect. Gradation physical properties, yes. Same functional group, yes. So your answer is A. A is not witnessed in a homologous series. Let's move on to the next question. How will you prove that C4H8 and C5H10 are homologues? Now this is not a direct question. This is, you can say it's a higher order thinking kind of question. C4H8 and C5H10 are homologues. How you can prove that? If they follow any of the two characteristics that we have just mentioned of homologous series. Now C4H8, can I say it follows the formula CnH2n? And this formula belongs to alkene family. Similarly, C5H10 also belongs to alkene family. So both of them belong to alkene family. They have the same functional group. So one characteristic is met. Let's find out whether they differ by CH2 unit. C4H8. If I add a CH2 unit, what do I get? C5H10. So they both differ by a unit of CH2 and hence they are homologues. Fine. Let's find out their molecular masses. We can say that since they differ by a CH2 unit, they differ by a molecular mass of 14U. Even this is true. So they have the same functional group, they differ by a CH2 unit and a molar mass of 14U, and hence we can prove that they are homologues. And I can say C4H8 is the lower homologue for C5H10 or C5H10 is the higher homologue for C4H8. Clear? Let's move on to the next question. Draw the electron dot structure. So they've asked a question from electron dot structure of the lower homologue of propyne. So what they have asked you, propyne, hydrocarbon, lower homologue, homologous series and electron dot structure. So they have combined together 3 topics, right? Propyne, all right. So this belongs to the family of alkynes. So first of all, we should know the molecular formula. The general formula for alkynes is CnH2n minus 2, where n is greater than or equal to 2. Prop means number of carbon atom equal to 3. Substitute the value 3 C3H4. Clear? 3 to just 6 minus 2. So for C3H4 is the molecular formula of propyne. So I'm writing propyne is equal to C3H4. But you don't have to draw the electron dot structure of propyne. Read, it's lower homologue. So we are going to go one step down. That is, we are going to subtract CH2. One carbon down. One carbon down is nothing but ethyne. You can directly do that. So it will have 2 carbon atom and the formula is going to be 4 minus 2 C2H2. So you are supposed to draw the electron dot structure of ethyne. Ethyne means alkyne. Alkyne means a carbon-carbon triple bond. 1, 2, 3 of this carbon atom, 1, 2, 3 of this carbon atom, one hydrogen this side, one hydrogen this side. So you have one electron here, one electron here. Fine. Now this carbon has 1, 2, 3. It's going to share one electron with this hydrogen, one electron with this hydrogen. Duplet is complete, octet is complete. I've already explained this in the questions on electron dot structures. So you get marks for this. Draw the electron dot structure of the lower homologue of propyne. You applied the concept of the alkynes, the general formula, and then found out the lower homologue. You get marks for drawing this correctly. Alright, so just do this properly in the rough or in the fair and then draw this correctly. Let's see the next question. The next question is an activity based question. There is an NCERT activity 4.2 and this is the question. So it could be a 3-mark question asked in your examination. A similar kind of question is there in your sample question paper also released by CBSE this year. Calculate the difference in the formulae and molecular masses for this, this and this. So it's both formulae also you're supposed to find out the difference and molecular masses also. Let's look at the first part. It is CH3OH and C2H5OH. Let me subtract. Fine. Can I say that we have C1H2? The difference is CH2. Fine. So the A part has a difference of CH2. That means what will be the difference in molecular mass is 14U. You don't even have to calculate. CH2 means you should remember it's 14U. Moving on to part B. B is C2H5OH and C3H7OH. So what is the difference? Again the difference is CH2, right? And the molecular mass difference will be 14U. Let's look at the C part. It is C4H9OH and C3H7OH. The difference is again of a CH2 unit and a molecular mass of 14 unit. Alright, let's move to the next part. Is there any similarity in these three? Yes, all of them differ by a CH2 unit and a molecular mass of 14U. Arrange these alcohols in the order of increasing carbon atoms to get a family. Increasing means from small to big. So we are going to write first CH3OH, thereafter C2H5OH, thereafter C3H7OH, and finally C4H9OH, right? To get a family, yes, we've got a family. Can we call this family a homologous series? Yes. Why? Because they have the same functional group OH, and OH, my dear student, is alcohol family. Alcohol, HOL, not A, all, alcohol family, right? CH3OH is methanol, C2H5 is your drinking alcohol or the ethanol. Why am I stressing on this? Because it's a sample question from here. This year CBSE has released a question paper. I'm going to do those questions in a separate video. So this alcohol is a covalent compound and most of the covalent compounds are insoluble in water and soluble in polar solvent, but ethanol is miscible or soluble in water in all proportions. I'm telling you this because the question starts like this, that this compound is it's soluble in water in all proportions. So you should remember ethanol, although a covalent compound, is soluble in water. It is one of the exceptions. Fine. So they are all alcohol family, right? And can we say that it's a homologous series? Yes, of course. They all differ by unit of CH2. They have the same functional group and a molar mass of 14U is also the difference between two consecutive members. Now with this question I come to the end of this video. Now this topic is very important, so please do as many questions as you can from this particular topic and do write and practice this particular topic. With this I come to the end of this video. I'm going to see you in the next video where I'm going to talk about isomerisms. That is also very important and you might have a question from there. So stay tuned to my channel and join me in the next video. Until then, take care.